Hello, everybody. Welcome to the Citus 13 release party. I can't believe that it's been so long since we last did it, more than over a year ago. Today with me, there's Abdullah from the Citus team.
Hey, Adam.
Hi, Abdullah. Nice to see you. So we have been quiet for a year, but that doesn't mean that we haven't been doing anything with Citus. We were actually doing plenty of things regarding bringing Citus to Elastic clusters, which is now public. We can finally talk about it, which is porting it to a completely new platform. And again, another public thing that was announced recently is DocumentDB that Microsoft open sourced, and that's a Mongo implementation, open source Mongo protocol implementation on top of PostgreSQL, on top of Citus that we actually run in production on top of Elastic clusters. So there's a lot of things happening with Citus that may not have been seen externally. Do you want to dive into some of those?
Thank you, Adam. Absolutely. As you pointed out, yes, it is true that we have been a bit silent for maybe what seems too long, but we certainly have been doing a lot of things behind the scenes. First of all, like everybody else in the team, I'm really excited that we are having this release party today for Citus 13. And this gives us a great opportunity to break the silence with some real news on what's happening on the Citus front. So what happened during the past year? We certainly have Citus 13 today with Postgres 17 support. We'll talk about that in more detail. In addition, as you mentioned, we have introduced Citus as Elastic clusters with an Azure Postgres flexible server. This is going to be our platform for improving Citus as a managed service in the coming months and years. We have lots of goals, and we are already working on some improvements around performance, scalability, manageability as it relates to Citus and its ability to scale out. In addition, as you mentioned, MongoDB vCore has been open source. That's also leveraging Citus as part of its platform. That's also exciting. We also did some experimentation during the past year, tried new ideas. Some of them worked out, some of them we learned quite a bit, and that's also helping us shape our plans as we move forward. Finally, we also re-strengthened our team. And some of these, we'll have a chance today to introduce some of our new team members today. And we are really excited about having them on board. They bring unique expertise across different domains, especially database and Postgres. So that's also giving us a chance to further improve Citus in the coming months and years. So really excited about what has been happening and the fact that we are able to get a chance to now start speaking about some of these developments.
Yeah, great. So maybe let's bring somebody onto the party and start.
Absolutely. So let's start with Ibrahim. Ibrahim has joined. Ibrahim joined our team. I think it has been almost 6 months now. He has joined our team as an engineering manager. Ibrahim brings 20 plus years of industry experience across a variety of domains. And he has been helping me in terms of kind of managing the widening scope of the team with a lot of different things happening across the Citus domain. So I'm really excited to have him on board. And we are also working on the roadmap for what's ahead together. So welcome on board, Ibrahim. And now that you have been with our team for almost 5-6 months, where do you see the top challenge in terms of managing the project as Citus evolves, and what excites you, as you look forward to what's ahead?
Yeah, thank you, Abdullah. Good questions. And indeed, it has been an intense 6 months getting to know the team, ramping up with Citus, learning more about Azure Flexible Server, the environment. It took some time for me. Looking at the work in front of us, the challenge I see most, I think, is to pick up the momentum. So as you just explained, the team has been quiet for some time from looking outside, let's say, but there were expectations from the community and also from from within the Azure services where Citus is central. And I see this quiet time in a way a huge potential and energy that developed, it built up. Now we need to convert this into a momentum and keep it up. I think we had a good start with the version 13 release, and now we also have the first patch following that with some bug fixes. So it's in the pipelines right now, publishing the packages. So yeah, we'll see. So I'm also at the same time grateful and excited because we have a great team. So we have some old folks, but also some new additions like myself. We're going to meet them today as well. So that's the excitement.
And the big thing about this release is, of course, adding support for PG-17. And I think that the best person to ask about that is Naisila.
Hi, everyone.
Hello, Naisila. Naisila
Adam.
doesn't need an introduction, like a big introduction, because you've done this a few times before, right? You're, of course, a
Right.
developer at Microsoft for the Citus project, but I've been to your talks in Athens on porting to PG-17, essentially. So what interesting things do you have for us today?
Right. Yeah. So it's true. I have actually been part of the release party of Citus last time as well. I have been working on Citus open source for about 4 years. And in the past years, I have been part of the project of providing a new Postgres version support in Citus. And yeah, so this time with Citus 13, so we have focused on bringing Postgres 17 exciting improvements to the users in distributed scale that Citus provides. And yeah, I will actually also be showing an example today, be doing a demo about JSON table, which is JSON table is one of the highlights of PG-17. And so the reason for that is that Postgres 17 in general has brought quite some enhanced management of JSON data. And the JSON table function in particular stands out because as you can understand from the name of the function, it takes JSON data as input and converts it into a regular Postgres table. So this actually means that developers can leverage the full capabilities of SQL on data that was originally in JSON format, which is usually a bit more complex to handle. Whereas with tabular data, you can just sort it, filter it, join it, and also use it in a from clause, which is one of the highlights of JSON table function as well. And so among other things, so in Citus 13, we have brought distributed query support for the JSON table function. And let me dive into an example. So I have prepared a cluster here with 3 nodes. So we have a Citus cluster with 3 nodes. And I want to create a table that actually has JSON data in it. So I'm going to have a JSON column here, and let's create a table for my favorite books and keep different book collection IDs in this table, and by inserting JSON data. And let's see how we can actually make use of this JSON data with the JSON table function. So let's first distribute the table. So this is the Citus signature function, create distributed table, and we will distribute it on the book collection ID. So we have now a distributed table, and let's also insert some JSON data into it. I'm going to insert a bunch of book collection IDs in our table. So I've inserted some books here, as you can see, so mystery, drama, poetry, and autobiography books. And let's also insert another collection for the sake of this example. So yeah, we have distributed table with the JSON data in it. So now we want to see how we can actually use the JSON table function. So before I actually run the query, I want to also explain it such that we can see how Citus will plan the query. So the first query I want to run is a router query, which means that we want to route this query to the specified book collection ID, which is the key in which we distributed our table. So as you can see here, so in this query, I am filtering on the book collection ID 1. And the way we use the JSON table function, so it has a little bit of a complex structure because you actually need to specify all the columns that you're gonna have in your tabular data. As I had inserted my JSON data in the table, so I have this favorites key here, and we specify the columns here. We have a key for ordinality, and we have the kind column, which we'll take from the kind key in the JSON data. And here we will have columns title and author as well. You specify in the JSON table function which column you are reading from. So this is the table column that has the JSON data. And we have named it as JSON table output. And we want to only look at the book collection ID 1. So before running it, what Citus will do here, so we have the query plan, it will create a task specific for this book collection ID, and it will route the query to the node. So we have here this node with port number 9702, and this node actually has the shard of the table which has book collection ID 1. So let's go ahead and actually run the query. And yes, so now we have the JSON data in a tabular format. So this actually looks quite nice and very understandable. So this is what we get from the JSON table function. And similarly, let's run like the same query, but this time we do not want to route to a single shard, but rather we just want to look at all book collections. So let's run another explain for multi-shard query this time. So we are not putting any anywhere clause on the book collection ID. We just want to see all the book collections. So this one will actually send a task to all the shards that we have of the table, and you can see a task count of 32 here, and because our table is sharded when like it has 32 shards. So it will actually parallelize this query among the 32 shards. So yeah, let's go ahead and run it. And
so Naisila is pushing down the JSON table operation. The parsing happens on each node individually, not
yes.
fetched back into the starting node. So to say.
Yeah, so only the final result is like fetched back to the coordinator. So yeah, so we can see here that we have actually retrieved all the book collections with this query. So yeah, these were like two examples of Citus distributed query. One of them was a router query, and the other one was a multi-shard one. And you can actually see more examples how we can use the JSON table in the Citus 13 blog post. And yeah, in general, so you can leverage the JSON table like beautification, or the way you can manage JSON data more simply, let's say, and you can leverage it in a distributed fashion as well with distributed tables in Citus. So yeah, thanks all for your attention.
One more question maybe. So out of curiosity, I assume you can
Sure.
just, for example, define a view over a JSON table query like that and expose that to some existing tooling, and that would still work the same way, right?
Right. Yeah. I mean, as long as the view that you are defining uses JSON table in like there are some limitations to using a JSON table because there are limitations similar to what we call like recurring functions in Citus. So as long as you adhere to those limitations, you can define all the views that you want. But in general, like for the most, like the vast majority of the examples, you can use a JSON table and you can make it part of views as well. That's right.
And you used it with JSON-B, but I assume it works the same way for just the plain JSON type.
Right, yes.
Thank you.
By the way, for these limitations and like more examples on how to use JSON table, we have the Citus technical documentation as well. It's all in the blog post. So I do invite people to take a look at it. Yeah.
Yes, we will cover it. Thank you. Okay. Abdullah, still there?
Oh, thank you, Adam. Great demo, by the way, Naisila. It's really exciting to see these live demos, and we have a couple more in the pipeline. So I'm going to keep it brief, but as exciting that the demos are, I think it's also exciting to introduce new team members. So I would like to introduce Mohammed to everyone. Mohammed joined our team about 3 months ago now, and he brings 20 plus years of experience across a variety of Postgres projects. So we are really excited, to have him on board, and he has been diving into Citus code base from the get-go. So that's great. So Mohammed, given your experience with many different Postgres projects, and now more recently with Citus in a hands-on fashion, what's your take when you think about keeping Citus aligned with Postgres mainline development? And what are the opportunities there from your point of view?
Yeah, hello. Yeah, thank you, Abdullah, for the introduction. Yeah, I think it's a huge strategic advantage and a critical aspect of Citus success story. Yeah, that it remains aligned with the community Postgres, and I believe that is due to some continuous effort being put into the Citus over the years, and a very smart decision made upfront to build Citus as an extension rather than a fork of Postgres, let's say. So, and I think because of this alignment, Citus can seamlessly adopt all the new feature that gets introduced in major Postgres versions, and it works with almost all new tools, extensions, and the Postgres ecosystem is huge and it works with everything. So, and another plus point of this alignment is that users, like, they enjoy the PG community support because the Citus is closely aligned with the latest version of Postgres. So the community support is also available for the Citus users. In nutshell, I think this close alignment with Postgres community not only ensures the compatibility, but also comes with a significant opportunities in scalability, geo-distribution, multi-tenancy, and real-time data processing, I believe. And yeah, these are some areas where I see the massive opportunities for Citus in coming future.
Awesome.
And you touched on a very good point, Mohammed, with the project being open source. There's actually no special version of closed source Citus that we are running for all the services that I mentioned, like Elastic Clusters, DocumentDB, or anything that we deploy on Azure, like Cosmos DB for PostgreSQL. Everything runs on the same open source Citus version that you can take home and deploy it yourself. So while in the past there was, like before acquisition, Citus had an enterprise version, we open sourced all of those features. So what you are running is what we are running in a truly open fashion.
Absolutely, and that's the beauty of true open source. Like, there's no two versions, there's just one version.
Yep.
Exactly. And I think this is going to continue being our promise to the community, just to keep this strong alignment with Postgres. So awesome. Thank you, Mohammed. Next, I would like to introduce Colm. Welcome on board, Colm.
Thank you.
Colm has joined our team again recently, late last year. He has tremendous experience across a variety of database projects over the years. I think it's probably more than 25 years now, right, Colm? And Postgres is one of those areas where Colm has spent a significant amount of time. So we are really happy to have him on board. So I know you have spent especially a lot of focus on performance optimization in your recent journey across different database projects. So when you look at Citus, I know it's a brief journey so far for you, but when you look at Citus, where do you see future opportunities in terms of performance optimization, domain?
Thank you. First of all, thank you, Abdullah, for the introduction. I'm very happy to be on the Citus team. A new chapter for me. Very exciting. So yeah, I mean, look, this is it's a great question. So yeah, there's a couple of things that have struck me in my time so far here. One I'd mention in passing is that in distributed query execution, for intermediate query results, we could make use of streaming I/O instead of temporary files in certain aspects of query execution. But yeah, that is one aspect I'm interested in and want to explore further. And in passing, I just mentioned we could potentially make use of caching, chunking of query results to help latency, and also prepared statements is a aspect I'm curious about to see if we could improve that in a distributed environment. So plenty of opportunities in this area, I see.
I love hearing that. Thank you. Colin.
Nice. Yeah.
So I think you have a demo for us, propagate merge, right? So we'll kind of shift it to you. And
this is correct. Yes, thank you. So I will share my screen. And we will take a look at one of the new features in Postgres 17 and how we have added support for this to Citus, to Citus 13. So the feature is the merge statement or the merge command. So you may be aware that the merge statement in SQL enables you to update a table in many ways, just in the one statement. So we will look at an example of doing that. So yeah, best way to explain is with an example. So we have a products table, very simple products table. We're going to distribute this by the product ID key. Okay, and then we have another table, new product info. Okay. So this is going, for the purpose of the demo, this is going to be a local Citus table. So the idea is we're going to update our products table based on data in the new product info. And we're going to use a merge statement to do this. So actually,
and may I interject you with a question? Maybe some of our viewers don't know what are local tables, like what is this Citus at local table to metadata? So how does a normal table differ when you call this?
So basically, this effectively creates a local table with one shard on the node that we are running on. So
that means that any other node then knows that this table exists. And when it has a query that refers to that table, it can then link back to that node that contains it, right?
Yeah. So is aware of the
even if it's local on one machine, other machines know where to find it. Nice.
That is correct, Adam. Yeah. Yes, thanks. So yeah, let's populate our tables before we actually run our merge command. So then we're going to take a look at our, Let's take a look at our merge statement. Get that here. Actually, before, yeah, we'll check the data. This is the data in our table. Okay, and now this is the merge statement that we're going to use. So I said at the introduction that in a merge command, you can specify different ways to modify the target table. So the target table that we're modifying is our products table, our distributed table, and we're joining this with our new product info table. And we specify 3 merge actions. Okay. First of all, when there's a match, in other words, there's a row that's present in both the target and source table, then we do the matched action. When not matched by target, this means there's a row in the source that's not in the target. So we take this action, which is to insert a new value into our target table, our products table in this case. And then the new type of merge action in Postgres 17 is when not matched by source. So when you specify by source, this means that there is a row in the target, but there's no corresponding row in the source table. So in this case, we basically update a field with some data just to show that, okay, here is a product in our products table that we didn't have a match for in our new product info. So we want to mark that in some way. And we can see that now when we look at our products table after our merge statement, that the rows for which we had a match, they've been updated by the new product info. The rows that was in the new product info, but not in our products, we've inserted a new row for those. And then the rows that we have in our products, but we didn't have new product information for, we've basically marked those accordingly. So simple use case, but I think it's useful in illustrating the different ways that we can use a merge statement. And with Citus 13, distributed tables can be updated with, we can use the new Postgres capability to update distributed tables with a merge command. And we can take a look at, let's take a look at the actual plan. So in this case, as we mentioned earlier, the source table is a local Citus table. So the way that this is actually executed is that Citus will repartition that local table so that the shards of the distributed table are updated correctly, correspondingly. But with Citus, the source can also be another distributed table. It can be a reference table, and it can also be a arbitrary query. So yeah, basically, you can refer to the blog post for Citus 13 release to see more information on how we support merge. But yeah, happy to take any other questions if there are. Nice.
So are there any specific limitations for Citus and using the merge query that you have top of your mind?
Okay, one off the top of my mind, Adam, is that the source, okay, if the source is a plain Postgres table, we don't support that. Okay.
Right, because the nodes wouldn't know what that table is if it's not in the metadata itself, and that's why you added that table to the metadata itself. Okay, makes sense.
Exactly.
Okay.
And then great. Oh, thank you.
You wanted to add another one?
No, just briefly, yeah, we don't support updating of reference tables. So if the target table is a reference table, that is not supported, but we feel that that's probably not a very common use case.
Right, because it would be a two-phase commit over all nodes in the cluster.
Yeah. Okay. So, but just want to mention in passing. Yeah.
Thank you, Colin. Hello, welcome back.
Hello. So,
for our third demo of the session. Mehmet is here, but before the demo, I guess an introduction is in order. So Mehmet is, well, relatively new to the Citus team, but he's not new to the Citus itself. Mehmet was with the Cosmos DB team before joining the Citus team, which there is a managed service offering on top of Citus. So Mehmet, you were there quite a bit, and then now joined the team and actively developing on Citus. You also did a lot on this latest version as well. So my question to you is, what was your one insight coming from the Cosmos DB days?
Thank you. Hi, everyone. I appreciate the introduction and the question. And during my time with Cosmos DB, I learned importance of staying close to our users. We constantly gathered feedback and iterated quickly, which taught me that understanding real-world usage and is the key build any robust systems. And now with Citus team, we focus on user-driven improvements, ensuring that every change we make directly enhance experience value for our users. I'm really excited where we headed actually together, and can't wait to see what will we build together next with Citus.
And a funny thing, I noticed that slip, Ibrahim, like, good evening. So truly, like, as a distributed database, we have a distributed team. We are all over the place. Some of us are like in Europe, Poland, Germany, Amsterdam, and Turkey, over the ocean. So and like even down south. So we are all over the place in different time zones. So that's why you hear those slips. But I think it's very fitting for a distributed database.
Yeah, distributed
right,
as well. And if it's okay, I have a demo about Citus' new expanded functionality on distributed partitioning table. And Citus now specify the update table access methods for distributed partitioning tables. All the changes propagate to all nodes, of course. Use generated identity column on distributed tables and add exclusion constraints that are constantly applied to across the cluster. And in this demo, I try create a table for orders, partitioning by a date column, and then distribute it, attach more partitions, and see this new feature in action. And let's start. First, let's create a partitioning table named orders parent that is partitioning by range or partitioning by range order date. We also use columnar to specify columnar access methods for the table. We define identity column here, which is custom start and increment. And Postgres 17 use partition by range, set access methods for partitioning table, and Citus propagate to its worker nodes. Oh, sorry. Yeah. And then we will create the first partition, which for the January month. And after that, we will distribute it. And now our orders table is partition table. We turn into the distributed partitioning table by calling our distribution to on Citus. We use order date as a distribution column because that's the column we are partitioning on. And let's create another table, another partition here. And for the February, since parent is now distributed table, this child will automatically will distribute it across the worker nodes. And next step, we can change the access method for parent table here to the heap. And existing partition won't be changed automatically, but future partition will inherit the new access methods. Let's check those. As we can see, the parent one heap, and February and January still columnar access methods. But all any newly created partition will become heap in this case. And as a next step, let's say we want to forward inserting 2 rows that has exact same order date and the same order ID. In here, and we can do this adding by exclusion constraints. Like in here, by this parent table, all existing partition, January and February one, and all the future partition you attach will be inherit this constraint. And let's see that by adding another partition for the another month, March. And here also we attach the partition to the parent one. And now the parent has an identity column and a constraint. This new child will be automatically inherit both. Let's verify that. In here, we can see all the table or the partition and table has identity column. It's for all of them, it's order ID. And now we can see the new constraint in action. If we try insert 2 identical order date and order ID combo, and second one will be failed. Let's insert the first one, which is this date, and it will be start with 100. And let's try the second one. This has 100 as ID. Also, it has same date. It should be failed, yes. As we can see here, is conflict with the existing key, order IDs, order date and order ID. And if you put that all together, what we will do, we create partitioning table with columnar access method and an identity column. And we distributed a table with Citus and then altered the access method to the heap, affecting all future partitions. And then we add exclusion constraint to parent and all partitions. Then we attach new partition, which automatically inherits the identity column and the constraint and the new heap access method. And then after that, we test it and verify it. And
very nice.
Thank you.
Very nice. Thank you, Mehmet.
Yeah. See you.
See you. And welcome back, Ibrahim.
Hello. So some more introductions. Alper. Alper has been with Microsoft for a little shy of a year, I think now. He joined a few months before me. He's coming with many years of experience from a diverse background. When you joined Microsoft, first you started with the work on PG extensions, and then joined the Citus team recently. So the question for you is, what do you find interesting about the Postgres world? And with your new focus, how do you see?
Thank you, Brian. Actually, my experience with Postgres began back in the time when I developed a custom logical replication service for our custom application that we're running in our company. And back then, I was really impressed by the extensibility features of Postgres, and like using triggers and other extensibility features, we could efficiently implement our like very custom logical replication service. And yeah, and since I joined Microsoft last year, I worked a bit on integrating Postgres extensions. That was also very exciting learning for me. And I'm currently part of Citus development team and pretty excited about it.
Awesome.
Yeah.
And also next up, Ebru.
Hello.
Hello, Ebru. Welcome. So you just passed your 1-year anniversary with Microsoft. And before that, you were with the academia. You were teaching at one of the best universities in Turkey. So how do you see PostgreSQL within the academic world and the student projects?
Well, thanks for the introduction first. PostgreSQL has its roots deeply embedded in academia. It started as a research project at the University of California, Berkeley, years ago. Sorry, I have mine with me. And it has many great features, but I think its strong focus on extensibility makes it a great candidate for exploring new ideas, including student projects or academic projects as well.
And also, I want to ask further on this extensions work, because you recently spent quite a bit of time validating various extensions on top of Citus, working with Citus in the flexible server environment. Alper was also working with you on this. And I know Adam sees this as a very critical effort.
I think it's an understatement. I think that right now, not many even extension developers test like cross extension compatibility, and they can have so many unexpected interactions, like from crashing PostgreSQL or not releasing some hooks, like not following the callback chain and leading to undesired or unpredicted behavior. So I'm actually pretty curious to know what you have found through all of that work that we actually did it for Elastic clusters to find that compatibility matrix with Citus.
Well, yeah, let me summarize that. First, like as a managed service on Azure Flexible Server, we want to enable all extensions that's on Flex, also on Elastic Cluster Citus. But we didn't want to do that before checking them if they work or not. Also, there are many great extensions allowed by Postgres users, such as PostJS, Vector, and the others. And while we don't want any incompatibilities or potential issues to prevent users start adopting Citus with like kind of other extensions. So we wanted to first assess the situation. Initially, we went through 70 extensions. As I said, this is a team effort. Per and I did run the maybe last mile, but it started before that. So we classified them as working, partially working, or that doesn't work. So, well, the doesn't work part is just either create extension fails or there is a crashing issue, etc. So all of them needs further investigation. We need to check if there is something on us on Citus that we can like improve or anything inherent with the other extension. But I'm happy to say that more than 50 of them, 52 of them was working out of 70 without an issue. And then general observations around that part, I can say like extensions introducing data types, functionalities over them, such as vector, PostGIS, raster, foreign data wrappers, extensions introducing new indexes. They all worked quite fine, the ones that we checked. The final classification we had was the ones that work partially. So what does it mean for us? So this means the extension works next to Citus, works fine on local tables, but has issues where tables distributed by Citus. So what this means, like, let me give you an example. One of the extensions is PG raw logs. That gives you the logs defined of a given table. So when you ask the logs for a distributed table, just always returns an empty set. Because the actual data and logs are defined over the shards that Citus distributes around the nodes. And well, like this one, in general, the extensions that provide functionality or provide actions over tables or give data for a given table might have issues with tables distributed by Citus. we find out that using Citus UDF, the running command on all shards can help in some situations. So we can use them as a way around, such as for pre-warming, it works. But not all of them has its own limitations. So when we see such a thing, we just take a note, put it into our backlog, like next to all the other great features that we plan for Citus. Hopefully, we will be able to say that it works nicely for more extensions as well.
Right. So for example, yes. Sorry.
I was just going to say that we want to share that data that we have now, just not the numbers, a few examples, but all of them, and we really want that to become a community effort to update and keep that list up to date.
So that's great. So I could go to the GitHub repository of the Citus project, for example, find like a compatibility matrix table, and for example, I want to use PG-Repack and find out, hey, does it work with Citus? Like, can I use it today? Are there any pitfalls?
Alper maybe can chime on that.
Yeah, I mean, PG-Repack was interesting. For example, it was also one of the extensions that we classified as like partially working. And PG-Repack has a client that we execute outside of Postgres that connects to the server to repack the actual table. But I mean, the step we fail with that was the creation of triggers on the table to capture the changes while the table is being repacked. And eventually we don't support creating triggers on distributed tables. But other than that, on local tables or individual shards, we can just use PG-Repack happily. Yeah.
Nice. Thank you.
Thanks.
Okay. So that's fun. And it's great to see a lot of the team members, but there's actually a broader community effort with Citus. It being an open source project, we are getting external contributions. So let's welcome back Naysila and Colm to maybe talk about some of the contributions that we've seen recently.
Right. So yeah, as Adam mentioned, we really value community contributions into Citus. And for this release, we've also had like some very important bug fixes that were contributed to Citus. And so I'd like to mention the 3 GitHub users in particular. So one of them is Cedric Villemin, and he's had contributions in fault tolerance by fixing a segmentation fault when calling a distributed procedure with a parameterized argument. And also we'd like to thank Karina. She's had contributions in crash tolerance in Citus. If she has fixed actually a server crash when trying to execute a node snapshot function on a single node cluster, as well as Philip Sedlak. He's had contributions in cluster management by improving function on moving shard placements to fail early if there's a new node that doesn't fulfill the requirements. So yeah, these are some prominent contributions on pull requests, but we also value issues, as Colm will talk about now.
Yes, thanks, Naysila. So yeah, we really do value the issues that our community users do file. A couple I'd like to mention in passing is Nick Oman, who about 6 weeks ago reported an issue to do with identity columns, which is actually fixed in the upcoming patch release. And also another user, Dioriwi, I'm probably completely butchering the name, but this user is very active in reporting issues to do with inconsistent query results. And we've fixed 3 of these in the upcoming patch release. So yeah, again, we really appreciate the community keeping us busy this way.
And for the contribution names, we will try to get them in on the screen on either post-production or in maybe description of the video itself, in case it was hard to decipher the actual account name, because I assume that you were referring to like the GitHub account name of the person who filed this.
Right, yeah.
Exactly. We are going by the GitHub.
Yeah, thank you. Again, we appreciate that. And with this, I guess we can go over some of the release notes, Ibrahim.
Yeah, let's do that.
Okay. Excuse me about that. So first off, Naisira mentioned the blog post. The Citus the 13 release blog post is full of information. It covers everything you've seen in these demos and on the release party and more, with examples that you can actually go and follow through. I'm going blasting through it because we are a bit out of time, so we are rolling through, so to say. But in essence, you can find a lot of what was discussed on the release blog post itself. You can find the release notes. They have a high-level overview of the changes that went into the release, and they also link to the specifics, specific sections describing all the support that was added. So you can also read into the details if you want to. Some of the ones that I find very nice is, of course, the JSON table that we saw on this demo. Personally, I like any new features in query plans. So explain, memory serialize. Those are always useful utilities in diagnosing performance problems. Those are my favorites. Do you have a favorite, Ibrahim?
Good question. I mean, I think for this release in particular, I like the JSON tables. I think it's, I mean, for me back then, JSON kind of complete separate from, the relational databases. Now they're getting into each other in a way, and that's fascinating.
Exactly. And finally, there's the Citus GitHub repository that we encourage you to go to, file those issues, do pull requests, do like, no matter how big or small your contribution is, we actually value it. If you're unsure how to contribute in some ways, you can always reach out, or you can create a ticket saying, hey, I would like to do this. And we will most likely try to help with that, align with you in how that can be done. And we feel very welcome to contribute to Citus itself. We would love to see you do that. And going ahead, we can also talk about some of the other things that we do here. There's a Talking Postgres podcast that's been running for a while now. It actually started as Path to CitusCon back when the POSET conference was called CitusCon. It's now called POSET. And it was a series of interviews with like upcoming speakers, and it turned into a regular event with a lot of PostgreSQL people outside of Microsoft and from within Microsoft coming in and talking about what they do, how they discovered PostgreSQL, like some interesting paths that they went through. And since I mentioned POSET, let me flip this. POSET, an event for Postgres, is a conference that we are holding every year. There's a bunch of, it's a virtual and free event, so everybody can subscribe, participate. And if you missed the call for papers this year, like, be sure to submit your proposal for next year. I believe we have a very strong lineup of talks, and we would love to see you there on the conference. Okay. So I guess this is the conclusion of this event. Thank you everybody who joined live or those who are watching the recording. We hope to do this more often, more frequently, with exciting features in the upcoming months. So don't be a stranger, drop by, and thank you, and bye everybody. Bye.
Thank you.
Bye-bye.
Thank you.
Bye.
Bye, everyone.
Bye.